Okay, so we're looking at 8.2. You guys, does this sound like a little reminder? If position is S, velocity could be in terms of S prime, right? If velocity is V, acceleration could be A or, true, it is the second derivative of, it could be V prime, yeah, or S double prime. Lots of different ways, right? So we've done that since, say, September. Let's work it backwards. Antiderivative of acceleration. Nice, you guys. Velocity plus C, maybe? Yeah, because I don't have any bounds on there. Antiderivative of velocity. It's going to get you position. And another way to put that is I might say displacement instead of position. Just letting us know that we are talking about that distance that I'm traveling, right? How far am I traveling? So, again, this is just going to be a little, these are like little cheat sheet for us to apply to these problems. So the displacement of a particle, if I give you the velocity, let's just say, all right, to find that displacement, we can take that integral of my velocity, and you could write v of t, or you could actually write velocity if you wanted to. Anyone remember what I would have to do if I want the total distance traveled? Total. You're thinking average, so we're going to get there. Total. When that police officer pulls you over, which I hope he doesn't, it's got to be absolute value, and I'll talk to you about why that is. We got to take the absolute value, and again, from A to B. They don't care about, oops, where's my other bar? They don't care about what direction you're going. They care about that you're speeding, right? Final position. Do you guys remember when I was training for that half marathon? And I literally met Miss Meister and Miss Smith 9 miles into the 18-mile run. So I met them at position 9 miles, right? And then I went ahead and I ran with them at a certain velocity. And so how we'd say, how do I get my final position? Sure, did I end at 18 miles? I did. But did I run 18 miles? No, I started at 9, ran 9 more with them. How would I say that? Is we'd say, okay, we've got, what's my starting position? I started at 9. I said S of A here just because they said position was S. I'm saying, hey, my starting position at T is A, and then I'm going to add on to that my displacement starting at that time period again. So at, let's say, if it would have taken them about an hour and a half, so let's say my A was an hour and a half here. My position an hour and a half in was 9 miles. I just drove there though. And then I'm going to take the integral of my position starting at that hour and a half and then going to that B, ending with them. I just cheated. And then lastly, that average velocity is what we've been talking about. To find our average velocity, what were we doing these last 2 days? Good. Integral from A to B of that velocity. Good job, you guys. This is just a little multiple choice of matching rather. If I tell you that the position is S and I tell you velocity is V, match the following expressions. Which one do we think total distance will be referring to? Yeah, A, B, or C. It's got that absolute value. So this one's definitely A. Agree with that. What about my position versus my change in position? Yeah, Greer's like, oh, the change in position is just her displacement. How far did she move from 1 to 8? That is going to be B, Greer. And then what do you think 1 is referring to? What's this little thing?
That's just saying, like, the point plus the distance.
Where I started, that point that I started at T is 1 in this case, right? 9 miles in, plus the distance that I'm going to go from 1 to then 8 hours. Sheesh, that would be our C. Very good. Okay, peeps. We love calculators. Let's go grab our calc. But before we grab our calc, let's write our setup statement. Particle moves along the x-axis. So you guys, it says, hey, this particle's moving along the x-axis. Woo! Life is crazy. This is what particles do in calculus. They move along the x-axis. That's it. Boring. Okay. It says the velocity is given. Here's V. If the position is x equals 1, when t is 2, what's the position when t is 4? Let's worry about a setup before we go type it in to our calculator. What are we thinking?
Just plug 2 in.
So what's my initial position, would you say? Where am I starting? You're saying when x, I don't really love that they use x, but you agree I'm starting at 1 at t equals 2.
And I'm plugging.
And then my integral is going to be from where to where, Mr. Greer? Yes, from where we started at t equals 2. And they want to know, all right, well, where are we going to end at 4? What am I going to put right here?
That T cubed.
That v of t thing. So you guys, let's go plug that into our calc. Let's see if we can handle that, if we can all get the right answer. You got 1.353?
I also got 1 point.
How is this one different, you guys? They didn't give us a calculator on this one. Oh, it's cool. Particle moves along the x-axis. Velocity is given. Here's my velocity. The particle is at x equals -2, at t equals 0. What is the position at t equals 3? Let's worry about our setup first. -2 plus integral of 0 to 3. 3t squared minus 4. Since I don't get to type this in my calculator, I'm going to write it out. Because now we got to do this by hand. You guys, this -2 is not affected by these bounds at all. So when I go find this antiderivative, I'm only going to do upper minus lower into this portion. Antiderivative of 3t squared. T cubed. Minus antiderivative of 4. 4t, very good. And that quantity is going to be evaluated from 0 to 3. Good job, good job, good job. My -2, he chilling. We got a -2 plus. What's up, bud? Yeah, what's my upper bound going to get me?
9 minus 12.
Careful, 3 cubed.
27.
27 minus 12. And then Mr. Nelson saying when I plug in 0 minus 0, it's just going to get me a 0 still. Agreed. Yeah.
The -2 on the outside.
Agreed. That my initial starting point is not affected by my displacement. Good call. Why do you think a lot of people are going to choose 15?
No parentheses.
Or they just
Forget the negative.
forgot to have an initial starting point? You know what I'm saying? We good with that, you guys? Okay, this one, notice I left a lot of space, and I did that for a reason. I know. You're welcome. You're welcome. Didn't sound very genuine.
Radix not here.
Okay, you guys, check it out. I'm giving you acceleration. I'm giving you velocity. Or not really. I'm just telling you velocity is v and position is s. I am telling you v of 0 is -2 and s of 3 is 0, and they want s of 6. Whew, there's a lot going on here.
What does it want?
Do you agree they want s of 6?
Yeah.
Yeah.
Colin!
Yeah.
Don't be sassy.
What?
Okay, you guys, how the heck am I going to get from acceleration all the way to position?
Double integral.
I got to take an antiderivative twice. Whoa, let's start with the first one. You guys agree the antiderivative of the integral of acceleration is going to get me velocity?
Yes.
Okay, let's go do this. Antiderivative of 4t.
2t cubed squared. 2t
You got it.
2t squared. You guys, what did we forget on here?
Plus c.
Yeah, here's the deal. This is why I left a lot of space. They said v, this is my velocity, right? They're letting us know v of 0 is -2.
Oh, so C is negative.
So we got to go plug this info in to get us a c value. My velocity is 2t squared plus 0, just like you said, Miss Soph. You're saying this is a t value. When I plug in a 0 for t, my velocity needs to be -2. So you said, Soph, my c is -2, and you're so right. So what is the equation of my velocity? 2t squared. Perfect. That's my velocity in this case, at this moment of time. In order to get position, what do we got to do to velocity? Yeah, so you guys, integral of velocity is going to get me my position or my displacement. Let's do it. Antiderivative 2t squared.
2/3 t.
2/3 t cubed, I love it, or 2t cubed over 3, minus 2t. Yes, Greer, with that plus c. What did they tell us?
S of 3 equals 0.
My position when t is 3 is 0.
Plug in
So 0.
Put 3
0.
in
0 equals
that stuff when you put it.
2/3 3 cubed minus 2 times 3 plus c. Whew, we can do this, people. What is 3 cubed? 27 divided by 3
9.
times that 2.
18.
18 minus plus c. What's my c going to be?
It's going to be negative 12.
Negative 12, right? Because we'd have to move that 12 over to the other side. So you guys, what's my position equation then? 2/3 t cubed minus 2t minus 12. And Mr. Nellis, they just said, all right, cool. That's my s of t, if you will. And they want s of 6. Now we plug in 6. You guys, this is free response. Do we really want to find that answer? I don't either. 2t cubed, 2/3 6 cubed minus 2 times 6 minus 12. We're skipping example 2. Let's go to 2016 because they didn't give you any equation. And they said, hey, particle moves along the x-axis. You know that's what we do for 6 seconds. Notice where 6 is over here.
Total distance.
And it says, ooh, what word did you just say, Greer?
Total distance.
Total distance traveled.
Absolute value.
Yes, they gave us velocity, you guys. These negative velocities are just letting me know that I'm going to the left. Yeah, say that word again. Area. What do I do with this area? Add it. Do not make it negative because that one word right there. If I were you, I'd circle that word.
It just said distance.
If it just said what is the change in location or what's its displacement, we would take the negative. Good call, Soph. You guys, what shapes do we want to picture these as? I'm down with the trap. 1/2, what's this guy's height?
2.
Its bases. 2 plus 3, very good, is 5.
So the area is 5.
So the area is going to be 5 because that half of 2 is just 1. And then this cute little trapezoid.
Bases are 3.
Ooh, bases add together to be 3. Good. What's my height?
1.
And then we got a 2 plus 1 are my bases.
So 3 halves.
3 halves, same as 1.5. So we got 5 and 1.5. Nelson, are they ready for you to not see that word total and do 5 minus 1.5? Ugh, that's brutal. Velocity. So on this guy, velocity is given and acceleration is given. And then I don't even know what I was trying to do here because I said X and there was no X involved. So I'm going to ignore this for right now. Sorry about that. You guys notice that I only bolded B. When I was making this packet, A and C are parts of this question. They're good. I'm hoping we got time to go do them, but B is just 8-2. You know what I'm saying? So let's prioritize 8-2 right now, and then hopefully we'll have time to go back. B says, find the total distance traveled from 0 to 6. What? Total, Daria.
Absolute value.
Total, Daria. And they gave you velocity and acceleration. Which one do I want to do absolute value for if I want distance traveled?
Velocity.
Velocity. So the antiderivative of that velocity, absolute valued, is going to get me my distance total distance traveled. Good question. So it says find the total distance traveled, or do they care about that final location? They're just curious. Exactly. So they don't care about where you started in this case. What are my bounds going to be? Good. Everybody, a lot of people miss this in our calculator. It's tough to type in, so just mind your parentheses when you type this one in. And let me remind you how we get a absolute value bars. So we're gonna go, everybody's typing this in, Stevie. Math, right arrow, enter, gets you absolute value bars. Make sure that we're in radians.
Couldn't you just like make it positive at the end?
No, good call. You can't. That +1 is not in the parentheses with your e to the t over 4. It's not in the parentheses. So make sure that you're typing it in and getting 12.573. You guys, let's do this last one here, 2022. So this was just from 2 years ago, their actual test. I like doing more recent ones, as well as I think the variables here are crazy. I think it can be very distracting. So I wanted you to see this. Okay, so check it out. This is the info they gave us. Notice that I only am asking part C, so they might have given us extra info that we might not need. Particle P moves along the x-axis that its position is, look at that, x sub p of t. Whew. And then they give us a particle Q moves along the y-axis that its velocity is v sub q of t. There's a lot. At time t equals 1, position of q is y sub q of 1 equals 2. So much stuff, right? And look what they're asking for. Find y sub q of t, the position of q at time t.
So you're,
We don't need any of our p stuff, right?
just in
Right. And so, but since this is part C, we would have used it for part A, B, or D potentially. Okay. So what are you saying? If they gave us the velocity of q,
we're just integrating.
yeah, I agree. And we're going to integrate 1 over t squared, but you guys, they aren't giving us a calculator. Ooh. And look what they said. They want the position of particle Q, and they said at t is 1, the position is 2.
So
It's like 2 right there.
So when t is 1, my position
Yeah.
is 2. So I'm going to start at 2. I'm going to say 2 plus all that stuff.
And we're doing this because we don't have bounds.
Well, we do. If this is my starting position at t is 1, what's this bound?
0.
2.
Careful.
Oh, 1.
Yeah. So if I'm putting in that position, that's happening at 1. So then I'm going to pick up at 1 and go all the way to
T.
t. This is a little funkier. That's why this is the end one that we're doing, because this is hard. We've got to do this one by hand. We got this, people. But how might we rewrite this?
T is negative 2.
2 plus exactly 1 to t, t to the negative second.
Negative 1 over t.
Good. Antiderivative of t to the negative second. T to the negative 1 over
T.
Negative 1.
negative 1. So,
Negative 1 over 2.
Negative 1.
so you're saying t to the negative 1 over negative 1 is just minus 1 over t? I agree. Guys, that's the only thing that will get affected by my bounds. Okay, just that little guy. So my 2 is chilling. That minus sign could throw us off.
Would that be inside the parentheses?
The minus sign?
Yeah.
We could. So we could go psh, psh. Yeah, we could totally do that. And that might help us make less mistakes, Colin. I dig that. It's the same diff. So I'd have negative, what would the plugging in my upper bound here get me?
Negative 1 over
And that's okay, because look, they said, what's the position at time t? They expect t's to be in my answer. So you're saying it's going to be negative 1 over t is plugging in my upper bound. Minus,
Minus 1.
minus,
It's just
Plus
plus
1.
yeah, minus the negative 1 over 1 would turn into plus 1. Is that the same as 3 minus 1 over t? Some extra time. I just want to practice and see if you can remember what makes, and we can just even do the setup. Don't even worry about typing it in. How would I find average velocity?
1 over 6.
1 over 6. From
0 6.
of which function? Velocity or acceleration? Average velocity.
Velocity.
Velocity, very good. So I'm fine with you just writing this, v of t. I don't even need us to type that in the calculator. I just wanted to remind us. Because I also want to look at C real quick. What makes something, oh, it says, the particle changes direction once. Find the position of the particle at that time.
Just put it in your calculator.
This is calculator active, which is nice. Do we remember, and again, this is just us prepping for the test at the end of the year. What makes something change directions?
X-axis.
Yeah, but if my velocity right now
Velocity changes sign.
My velocity changes signs. If I was going right and then left, wasn't my velocity going positive then negative? I changed signs there. So can we graph velocity? Let's go do that, you guys. Let's go graph that velocity graph. They gave us velocity. So we're all in our y equals screen. We're going to do 2 sine of e to the x over 4 get out of that exponent, get out of that parentheses, and then do plus 1. And maybe you need to do a little zoom standard.
0 to 6.
Oh, yeah. He's saying don't go zoom standard. Let's change that window from 0 to 6. Thanks, Colin. And if I were you, I would just throw, what does that graph look like? Just real willy-nilly. Looks like this. That's my velocity graph.
It's at 5.
It says it changes directions once. We're looking for this value, right? When my velocity changed signs. So how do we do that in our calculator? Second trace, 0. Find the 0. To the left, hit enter. To the right, hit enter. What'd you get?
5.196.
5 point. I love that you said 3 decimals. I appreciate that. And it says, hey, it changed directions once. You're saying that's when that's happening. Find the position at that time.
Just integrate that.
Integrate. You're right. Integrate velocity from 5.196 is going to be the highest. So it's going to be the lowest. Exactly. Because we started at 0. That's great. And we're talking of velocity. And I'm actually okay if we don't even type that in our calculator.